So I'm going to go over the answers about these questions because they're common mistakes or common kind of questions that you see that people make common mistakes on. So I wanted to show you sort of the process of how to do that. So the first question, scientists were attempting to determine the number of goldfish in a pond. On a day there were 50 fish, so the 50 is like the initial amount, that's important. And that was on day 4, that's also important. The growth rate fish in the pond is modeled by the equation. So this already is the derivative. T is the days. Determine how many fish were in the pond at the end of the 9th day, and E will be in your answer. So since day 4 is when we have the initial amount and we're looking for day 9, that means that we're going to start at day 4 and go to day 9, and we're going to take an integral. Because we're now wanting to know how many fish were in the pond, and you're starting with the rate to get the how many, it's an integral. So we're going to take the integral of e to the square root of x over square root of x from 9 to 4. Now, because day 4 is where there were 50 in the pond, we're going to add 50 to that, because from 4 to 9, the integral of 4 to 9 is how much the fish has changed. So like how much it's increased or decreased. So if you start with 50, you'll find, and add or subtract the amount there, you'll get out the total. So we're going to find the antiderivative here. That's u substitution. So u is the square root of x, and du is 1/2 x to the negative 1/2. So that means that in this problem we're missing a half on the inside, which means I can put a 2 on the outside. So I'm going to have 2 times the integral of e to the u du, which is 2e to the square root of x. Then I want to evaluate it at 4 and 9. Plug in the 9, so that's 2e to the 3. Plug in the 4, so that's 2e squared. And then you have your 50 at the end that you want to add to it. So this is the amount of fish in the pond. Alright, the next question. We've done one like this recently on the free response, but it's asking you to find the second derivative of dy dx equals 1 plus sine of y. So this is kind of like the implicit differentiation stuff. So the second derivative would equal the derivative of 1, which is 0. The derivative of sine of y is cosine of y, but you have to remember to put your y prime with it. And then for the final answer, you substitute in what your derivative is, which is 1 plus sine y. So that's the second derivative, and you could use it however you needed to, depending on what the question was asking you. So these next 2 questions, I think that if they show up, they would show up on the multiple choice. And probably you could use the choices in the multiple choice to figure out the answer easier. Both of these questions are involving arctangent and arc sine. So just real quickly, I want to remind you the derivative of arc sine is 1 over square root 1 minus x squared. And the derivative of arctan is 1 over 1 plus x squared. So this one has to deal with arctangent, this one has to deal with arc sine, just because you can sort of look at the form of it. So on the first one, remember the dx is sort of, just sort of separate. So it looks like it almost is arctangent if that right there was something squared. So I'm going to rewrite it first and make it 2x squared. Now it looks like arctangent. The only problem is the thing in the parentheses is supposed to be only x. Well, it's 2x. So you fix that by letting u be 2x. And du comes out to be 2. So you put a 2 in, take a half out. So then you would have the half times the integral 1 over 1 plus u squared, which now does look like arctangent. So the antiderivative is 1/2 arctangent of 2x plus c. Now on the second one, it's a little bit more complicated, I think. just because the square root's there and everything, but it's basically the same process. Think of it as the integral of 1 over square root 1 minus 4x and then squared. So 4 squared is 16x squared. So kind of the same. You would let u be 4x and du is 4. So this time you've got a fourth on the outside. Integral 1 over square root of 1 minus u squared. So that would be arc sine. So 1/4 arc sine of 4x plus c. Alright, the next ones are involving some limits. The first two is using that old limit formula. And the limit formula, I'm going to write it down just so you have it, but it said the limit as h approaches 0 of f of x plus h minus f of x all over h. And see, that's what stands for the derivative. So that's what's going on number 1 and number 2. On number 1, the f of x is 3 ln of x. And basically, they just want to know what the derivative is. Well, a reminder, the derivative of ln of something is 1 over the thing, so it's 3 over x. The second one, similar kind of question, except it has a 3 plugged in for x. So basically, we have f of x equals e to the x, where x is 3, and we want the derivative of that. Well, the derivative of e to the x is e to the x, and then we plug in 3. Now the third one, I don't know an easy way to do that one except to multiply everything out. And for the sake of time, I'm just going to kind of multiply it out for you. You're going to get 12 plus, let's write that in a different color so you can see it better. 12 plus 12h plus 3h squared plus 2th. Hang on. That's a 2h. Sorry. I went ahead and erased some of that other stuff just to get it out of the way. And then minus 14. And then we want to factor out an h, because the 12 and the 14. So this is a 2 plus h. I knew something weird was going on right there. Okay, the 12, the 2, and the minus 14, that all goes away. Factor out an h of what's left, so you have 12 plus 3h plus 1. H's cancel. Plug a 0 in for h, so you get 12 plus 1, which is 13. Alright, number 9. The graph of the derivative to the right is f prime of x. So the question is asking you to figure out where f of x is concave down. Remember that f of x is concave down, where f double prime of x is negative. Well, since this is the first derivative, f double prime is the derivative of that. So I'm looking for where the slope of this graph is negative. The slope of this graph is negative from here to here, which is approximately from negative infinity to 1. Just be sure to explain it if it were on free response. That is because f double prime of x is negative. So this question, number 8, is asking us to write the equation in terms of y. This is a differential equation. The first step you have to do is to get the y's and the x's together. So I'm going to cross multiply. I get y dy equals negative x dx. To solve it, I'm going to take the antiderivative on both sides. Multiply everything by 2. Remember, you can put a 2c or another c, doesn't matter, whatever you want to do. Then you want to take the square root on both sides. Oh, and I left off the negative right here. Okay. So now we have it solved for y, so now we need to figure out what c is. You're going to use these other two values. So -2 equals, now, trying to decide if it's a plus or minus, it'll tell you it's a negative, and that's because the y is negative. If the y is negative, it'll be negative. So it's the negative square root of negative x, which is 1, squared plus c. So divide by -1 and then square both sides, so you get 4 equals -1 plus c. Add 1, so c is 5. So your final equation is y equals negative square root negative x squared plus 5. Okay, so find both the average rate of change and the average value. So if I'm going to find the average rate of change, that represents slope. Average value is an integral. So if I'm going to find the average rate of change, I'm going to plug in 0 and 4 into that equation. So f of 4 is 40. F of 0 is 0. So the average rate of change is 40 minus 0 over 4 minus 0, which is 10. The average value is the integral from 0 to 4 of the function. And then you divide that by 4 minus 0, or multiply by 1/4. If I'm going to do this by hand, just so you can have some practice there, antiderivative of 3x squared is x to the third. Antiderivative of 2x is x squared. You want to evaluate that at 0 and 4, multiply by a fourth. You would get 64 minus 16 over 4, which is okay to leave it that way. If you simplified, you do get 12. Number 6. The question's asking you to find the coordinates of the relative mins and maxes and what the absolute value or the absolute maximum value is. So first of all, I'm going to find the derivative. I'm going to factor it. Set that equal to 0, make a number line. Plug values into the derivative to find out positives and negatives. So we know that we have a graph that is increasing and then decreasing and then increasing. So there must be a maximum at 1 because f prime of x changes from positive to negative. There must be a minimum at 3 because f prime of x changes from negative to positive. All those words that I just said probably need to be written, but I'm just going to go ahead and show you how to get to the final answer. Because the graph looks like this, that means that there's a minimum at 0 and a maximum at 4. So if I'm trying to find, so I explained the relative mins and maxes, but now to find the absolute max, I need to take all the maxes, which I know are at 1 and at 4. I want to plug those into the original equation. They both give me 10. So don't forget when it says maximum value, it wants the y value, and the y value here is 10. Okay, so number 5 says coordinates of points of inflection. So that's where I find the first derivative, and then I find the second derivative. I make a number line with the zeros on it, plug the values into the second derivative. Whatever the number line's based on is what you plug it into. So there's no points of inflection because f double prime doesn't change sign. Now if I do g prime of x and then g double prime of x, it's hard to figure out what goes on the number line, but the derivative is undefined at 0 because you've got that negative power. Plug values into the second derivative, so there is a point of inflection at 0 because f double prime changes from positive to negative. Okay, number 4, the first question says to find d prime of x. Well, that means find the derivative of the integral. Remember, the derivative of the integral you take the integral, you plug in the value that's on the integral for the t's, and then you multiply by the derivative of what was on the integral, so there should be a 4x multiplied by that. You could probably leave it like that. I don't foresee them having issues there. The derivative of m, the only difference there is that the x is at the bottom, so there's negative. So you put a negative on the outside and then plug in your x, negative x to the third minus, actually a plus 4x. Sorry, it's a minus. And then plus 6. And now the derivative of this one. What you do there is you multiply by the derivative of x to the third, plug in x to the third, 3 times 3 is 9. Then you multiply by the derivative of 3x, and then you plug in 3x into all of it. So there you have it. That's the second fundamental theorem of calculus. Alright, number 3. Put the following in an increasing order. Alright, so h of 2 would mean the integral from 0 to 2, which would mean the area of this part right here, so I know that that is negative. H prime of 2 is the derivative of that, so I know that that is 0. H double prime of 2 is the slope at 2, so I know that is positive, so it already is in increasing order. Negative, 0, and positive. Okay, number 2, it's a multiple choice question, and this one's kind of tricky because we usually solve this differently, but I wanted you to see how you're really supposed to solve it if it were multiple choice. It's u substitution, and u is square root of x, and du is 1/2 x to the negative 1/2. So all you're missing is a half, so there would be a 2, and then an integral, and then an e to the u. Now, since the multiple choice question is not worked out, they actually changed the 3 and the 2, and they changed it based on what u was. So you plug in the 3 and the 2 right there, and you would actually get square root of 3 there and square root of 2 there. So the answer would be C. That's a very tricky one because we solve it differently, but just wanted you to see that just in case. Number 1, it asks when the velocity is increasing and when the speed is increasing. Alright, this original graph I think is x of t, so it doesn't say anything about it. So velocity would be increasing where the second derivative is positive. Well, this graph right here is the original, so second derivative will be positive where this graph is concave up, so second derivative is going to be positive there. And that means that velocity is increasing from 0 to approximately 3. They would have to give you information on whether that was 2 or 3 where it changed. Then it says, where is the speed increasing? Well, speed increases where f prime is positive. Speed is the f prime is positive and f double prime is positive. So the red is positive, but also when I think about the f prime being positive, f prime is positive here to there. So they have to have the same signs basically. And so here to here is one place where speed would be increasing. But see, also, the interesting part is that speed also increases where f prime is negative and where f double prime is negative. So f double prime will be negative where it's not red, and the first derivative is negative there. So this is where it would also be negative both places. So speed is increasing from 1 to 2 and also 5 to 6. It's kind of funny, I'm now realizing that there was more information to that graph. So really it would have, because that point of inflection was at 2, I kind of drew it wrong. It actually changed right there. So that's why 3 wasn't included in that graph. So sorry. If you have questions about that, please let me know. I'll talk to you later. Very last question. It asks you to find the derivative of that whole thing. The derivative of 2x is 2. The derivative of that whole thing, that's where we plug 3x into f of x. And we multiply by the derivative of 3. It tells me in the equation what f of x is. So I'm plugging in 3x into the 3x. So we have e to the 9x plus 2. Good luck on your test. Don't make the same mistakes. See you Monday.